Okay, let's look at an example now as we apply these equations of motion. For example, here says a motorcyclist travels along a straight road at the speed of 27 meters per second. The brakes are applied. Okay, the motorcycle decelerates at a rate of 6 meters per second square. The distance the motorcycle travels before it stops. That's what we need to find out. So this is the case that I was telling you about. We have a motion in here. I think, if we put it this way, in this case, the velocity of this is going to be 27 meters per second, but the acceleration of this is going to be minus 6 meters per second square. How come is the acceleration negative? The reason is because the motion this way is positive this way. We make this convention just about every problem. Okay, so the first thing is establish a positive coordinate system in the x direction. That's what I was trying to tell you. You say, hey, this is my coordinate system. Either you use S or you use Y here. I like X, just X and Y. And then it says, since the acceleration is giving us a function of time, integrate once to calculate the velocity. Now this is interesting because in here, the acceleration, do you notice? This is not a constant. This is a function. So we have to go back to the concept. The concept is that the acceleration is dv dt, and that the velocity would be the integral. This is why it's important to know the basics. Integrate both sides. So the integral of between b0 and b of dv, and the integral between 0 and t of minus 6t. So you can see in here, this is the integral, this one, and this would be really is actually, if you don't see this, let's actually do it more clearly here. We could just say, look, the integral of minus 6t like that, dt. Okay, so do you remember from your integration how you actually do this? You have minus 6 times the 1 over the number t plus 1, so this would be t squared. So this would be like 1/2. So this is 1 plus 1 in here, and this would be t to the n plus 1, so it's 1 plus 1 like this. Yeah, and for this reason, what you have in here is minus 6 times 1 divided by 2 t squared, you see? And this is what gives you minus 3t squared, like that, which is what you see in here. This is what I'm trying to tell you. I would like to model a little bit for you in the sense that I want you to be inquisitive, I encourage you to look as to why this is the result like that. Don't take it at face value, either what the book says or what I say. Just sit down and do it yourself, right? And you'll be glad you did. So I'm going to say determine the amount of time required for the motorcycle to stop. So you see, what equation should we apply in here? And here you know that this is you have that the velocity final is v sub 0 plus at. This is we learned just now. And keep in mind that a is a negative number here. Velocity in final is 0. The initial velocity is 27. And then minus, you have this 60 like that, like this, see? And then this will give us the ability to calculate the time. So see, move this equation will have this would be what do we say? This would be 6 t squared is equal to 27, right? Yeah, 3. No, 6 is 3t squared. See, I am not doing well here. This came from the previous um, from the previous. Know that the velocity was. So I have in here. This is 3t squared. Then if you do that, then you divide this, you know, from here, t squared is equal to 9, and obviously from here t is equal to 3 seconds. See, that would be the answer to this problem. Okay, a little bit. I think we don't want to get confused here. Perhaps we'll erase this. How do we do this? We'll erase this thing in here and then give rise to the next. Hopefully that's already assimilated. There you go. How do we calculate the distance traveled in t seconds? By integrating the velocity and using the initial position at 0. So you can see very clearly that the velocity is dt, and so we are going to integrate this both sides. So this the position is from 0 to t of 3t squared plus v0, which was the velocity in there. And so this would be s, and would be the integral of t would be 3t cubic over 3 plus 27 times t. If you feel more comfortable, we can do this separately in this. I think we could try. Okay. What I'm trying to say is let's do this. Yeah. Just separately, because in here simplify. I don't want to simplify. I want to make sure that you get an exercise on how you do this integration. So why don't we just go on to our notes in here, and then perhaps we find another space in here that we have, so that we can do it specifically. So let's see. So you have the integral of what did we say was s ds, just using the terms on the textbook in here. This is minus 3t squared plus b0, right? The way it's in here, we have this is minus 3t squared plus b sub 0, like this, right? dt. So in here we have this, I like to do it and perhaps over here with this. So if you integrate this, you're gonna have the integral of this is just s between s sub 0 and s, and this would be between t sub 0 and t. This would be minus 3 times, this would be t to the 2 plus 1 divided by 2 plus 1, like that, plus t times b sub 0, like this, and this whole thing between t sub 0 and t. So this would be this would be s. The position is going to be, you see, this 3 is t to the third plus t times b sub 0. And we have to go back to the numbers in here. Yeah. See, that's 3, and then the other is 27, right? So that's how you get it. You see, this is 3 to the third plus 3 times 27, like this, right? Am I right? Yeah. And that will give you 54 meters. This is going to give you 54 meters. Okay? So that clarifies how that result gets in there. And I will solve the example in detail.